Hi, I just want to give you another example of an epsilon-delta proof so that you can have one to study with. So we are going to prove that the limit as x approaches 2 of 3x minus 1 is equal to 5. Now you can see that this is true because obviously 3x minus 1 is defined at 2, and if you plug it in, you're going to get 5. But we're going to use the epsilon-delta definition to prove this. So to start off with my proof, I'm going to kind of outline it. We always want to let epsilon be greater than 0. That's our first step. Even if you don't know anywhere else to go from there, go ahead and write that down. You'll get at least a point or two. We know that we are going to assume that the absolute value of our x minus c, so remember this is the c, is between 0 and some delta. We don't know what the delta is yet. And we know that eventually what we want to prove is something along the lines of this. We want our f of x minus L. So in this case, f of x is the 3x minus 1. And the L is the 5. So f of x minus L would be 3x minus 1 minus 5. Absolute value is less than epsilon. So that's our goal. So after that, we will be able to say, therefore, the limit as x approaches 2 of 3x minus 1 equals 5. Okay, so the next step is that we want to find what this delta is so that we can have a value for it, because remember, epsilon is generic. It can be any number you plug in, but you only have to have one delta, and so we can let it depend on the epsilon. So we're going to start with what we want, which is this statement down here. I'm just going to do some scratch work off to the side. So I've got the absolute value of 3x minus 1 minus 5 less than epsilon, and we're going to try to get to this portion right here. So that's the goal. So I'm going to take that and simplify it a little bit. That gives me 3x minus 6. And then you'll notice that you can factor a 3 out here. So that'll be 3 times x minus 2, still in the absolute value bars. And the absolute value of 3 is just 3. So I can bring that out of the absolute value bar, because it's not going to change anything. And then if I divide by 3 on both sides, because it's a positive number, I now have the absolute value of x minus 2, which is what I wanted, so we can let that epsilon over 3 be our delta. Okay, so I'm just going to come in and fill in what I found. We're going to let this be epsilon over 3. And then from there, I'm going to try and build the proof. I want to get that this is less than epsilon. So I'm going to start out with that. And we're just going to do kind of a chain of equals. So simplify it, just similar to what we did here. So that'll be 3x minus 6, which is 3 times the absolute value of, well, you can skip straight to this step. You don't have to pull it out twice. So we can make that 3 times the absolute value of x minus 2. And based on what we know up here, that x minus 2 is less than epsilon over 3, we can say that that's less than 3 times epsilon over 3. And those two cancel to give us epsilon. So following the chain here, that tells us that the absolute value of 3x minus 1 minus 5 is less than epsilon, which is what we get. So our proof is done, and all you need to do is draw your little box to show that you were done. And that is it. That is an epsilon-delta proof.